Hello, this is Mr. Anderson for Keller Community College. We're going to be looking at Section 8.1, which is Chapter 8, Section 1 of Quadratic Equations. This is going to be for Intermediate Algebra, Math 121. We're going to start off today with the principle of square roots. The principle of square roots deals with this idea that if you take the square root of a number, you have a plus or minus possibility for that number. So the principle is an if-then statement that says, if x squared equals k, therefore x is equal to the square root of k, or x is equal to negative square roots of k. So to put that in a concrete example with some numbers here, if I have x equals 9 and I decide to take the square root of both sides, so therefore I'm taking the square root of x squared and the square root of 9, then x is going to be equal to plus or minus 3. You know, the square root of 9 is 3, and the square root of 9 is also negative 3. So when you take your square roots, you have to consider the positive and negative answer of that. So to do some solving for x here, I'm going to move this 8 to the other side. So x squared is equal to positive 8. Then I'm going to take the square root of both sides, and in doing so, I'll just put the little square root above both of these. Then this is going to be x is equal to plus or minus the square root of 8. Now, the square root of 8 can also be simplified to the square root of 4 times the square root of 2. And this then makes x is equal to plus or minus the square root of 4 is 2, and the square root of 2 is 2 as well. And this is the most accurate it can be. It shows you that there are two answers to this problem, and if you went into your y equals on your graphing calculator, you can see that there are two places where this hits ground. And this decimal location, or 2 times the square root of 2, positive and negative, is where it lands. Now things will be a little bit easier if you have rootable numbers. So in problem 2, we're going to have 36x squared is equal to positive 25. I just move the 25 to the other side by adding. Then dividing both sides by 36, x squared is equal to 25/36. Then I take the square root on both sides. X is equal to plus or minus the square root of 25/36. And using our quotient rule from the previous chapter, I can split this into the square root of 25 divided by the square root of 36. So x is going to be equal to plus or minus 5/6, because the square root of 25 and square root of 36 is perfect. Now, what we learned in the end of the last chapter is that sometimes things aren't that pretty after we take the square root. So notice I have, by subtracting the 4 from both sides, x equals to negative 4. Now if I take the square root here, x is equal to plus or minus the square root of negative 4. Now we can't take the square root of a negative number unless we get imaginary numbers. So I'm going to make this the square root of 4 times the square root of negative 1. And that means the square root of 4 is 2. Now don't forget our plus minus here, because we have two possible answers, a positive and negative. And then the square root of negative 1 is I. So the answer to number 3 is x is equal to positive or negative 2i. Now, looking at here, I already have this isolated, so if I take the square root of both sides right now, I'm going to get the square root of 100, which is plus or minus 10. Again, to show you the step that I did not write down, I am going to take the square root of both sides to get rid of the square. And that means that my square root of 100 is plus or minus 10. This is going to give me, when I isolate the x, I'm going to move the minus 1 to both sides, but now I have two answers. I have x is equal to negative 1 plus or minus 10. So this is, I'm going to branch using my little arrows here to show that I'm going to have negative 1 plus 10 and negative 1 minus 10. Negative 1 plus 10 is going to be 9, and negative 1 minus 10 is going to be negative 11. So I have two answers to my problem, 9 and negative 11. Problem number 5 is very similar to problem 4. If I take the square root of both sides, I get x minus 1 is equal to plus or minus the square root of negative 49, which I can break into the square root of positive 49 and the square root of negative 1. This gives me x minus 1 is equal to plus or minus 7i, because I have the square root of 49, which is 7, and the square root of negative 1, which is I. Moving the 1 to the other side, x is equal to 1 plus or minus the square root of 7, or just 7i. Now, unlike problem 4, which had two answers because all I was left with whole numbers, this right here is an acceptable answer. You can choose to write it twice, 1 plus 7i and 1 minus 7i, but that really doesn't help. It just writes the problem twice and doesn't do anything more. Now, problem number 6. We are going to look at how this can be broken up, and this can be broken up as a factorable problem. Two numbers that multiply to make 9 and add to make negative 6. This is going to be x minus 3 equals 100. Putting this together here, to simplify my work, this is x minus 3 quantity squared equals 100. So what I'm going to do to get rid of the square is do the opposite, take the square root. In taking the square root, I have left on the left-hand side x minus 3, and on the right-hand side plus or minus 10. Now what I'm about to do is add the 3 to both sides. So x is equal to 3, positive 3, plus or minus 10, which branches this into two problems. The first problem is going to be 3 plus 10, and the second problem is going to be 3 minus 10. So that gives me 3 plus 10, which is 13, and 3 minus 10, which is going to be negative 7. And those are my two answers there. Okay. A couple more things here. Problem number 7 and 8 is just the same way of doing the problems that we've done before, except that we are going to just show a different way to write it. So here we have x minus 2 quantity squared, such that f of x equals 25. So this is another example of the transitive property. If f of x is equal to this, and f of x is equal to this, then this underlined in blue is equal to this underlined in blue. So that is going to be my setup. And you can see from the previous problems we've done, this is not too far different from what we have been doing. We're going to take the square root of both sides. So I have x minus 2 is equal to plus or minus the square root of 25, which is 5. So I'm going to move my 2 over to the other side here. And so I have x is equal to 2 plus or minus 5. So I can split this up into two different problems. 2 plus 5 equals 7 equals x, and also 2 minus 5 equals negative 3 equals x. Now the same thing goes for problem number 8. We are saying if g of x is equal to this trinomial and g of x is equal to 9, then the trinomial is equal to 9. Now, it's important to see that this trinomial here can be factored. Two numbers that multiply to make 16 and add to make 8 are 4 and 4. So that means I have x plus 4 quantity squared equals 9. So I take the square root of both sides. If I take the square root of both sides, I have x plus 4 is equal to, is equal to plus or minus the square root of 9, which is 3. Which means I got to branch this number out in two places, because I'm going to have x is equal to, I'm going to move the 4 to the other side, negative 4 plus 3, and then x is equal to negative 4 minus 3. So x is going to be equal to negative 1, and x is going to be equal to negative 7. So my two answers are negative 1 and negative 7. Now it says here, before flipping the page, factor these two problems. And what do you notice? Well, what I'm noticing here is that I can factor this into a combination of something squared, because the two numbers that multiply to make 25 and add to make 10 are 5 and 5. And then here, the two numbers that multiply to make 36 add to make negative 6 is going to be x minus 6, or x minus 6 quantity squared. So what's important about these problems is that these are called perfect squares. And what we're going to be doing is completing the square we're going to be completing the square on the next page, which means that we will have problems that will have an x and a 5, an x and a 5. If you take a look at this problem here, this would be x squared, this would be 25, and then this would be 5x, 5x. So this is an example of completing a square that is already completed. This is a problem that is x squared plus 10x plus 25. On the other side here, this square would be x and a negative 6, x and a negative 6. So our insides would be x squared, negative 6x, negative 6x, and positive 36. So you can see where this x minus 6 quantity squared and x plus 5 quantity squared is going to be part of my next side of this worksheet, which is going to be all about completing the square. And that's where our video is going to start next. Thanks for watching.